But if you're interested in finding the rationale behind why mean is equal to b plus a by 2 for uniform continuous distribution and variance is b minus a raised to the power 2 upon 12 for uniform continuous distribution, then this video is for you. And I would say that even if you're not interested in the concept of how to derive mean and variance, but thematically, you need to have a bleak, intuitive understanding of the same. The reason is because if you're aware of the probability density function and how probability density function helps you to derive mean and variance, at least you know that if you get any new distribution and if you have to find out mean and variance, you can easily find out with the help of the method that we'll discuss today. Okay, so we know that the mean is the expected value and the formula for mean is what? Summation of xi upon n. We're aware of that. That is our moment one, correct? And the mean formula is what? Summation of xi upon n. But that is the formula with an assumption of equal probability, right? We know that. We discussed in moment one session. Now, the universal formula for mean is summation of pi into xi. This is the universal mean formula because in this formula, we are not taking that assumption that every outcome has equal probability. Now, this summation, the problem with this summation is that this summation will work fine if we have the discrete distributions. When you're working in the field of continuous distribution, this summation doesn't make sense because xi will have infinite values. So you cannot do summation one by one, you have to do integration. So therefore, integration of pi into xi, and the right way to write it as pi into xi into dx. Okay. This is number one concept that we have to understand, that in the continuous distribution, it is integration of pi xi dx. This is the formula for mean. Okay, number one. Second, in the last session, we introduced the probability density function of uniform continuous distribution, right? That was d minus c upon b minus a. If you have forgotten about the formula, then revisit the lecture, the last session on uniform continuous distribution, where we discussed PDF. Actually, this is not the true PDF of UCD or uniform continuous distribution. The true PDF of UCD is this dx upon b minus a. Let's understand why. So dx is a very small length that we have taken in the uniform continuous distribution. Dx, somewhere here between a and b, we have taken dx. So dx is actually a length which tends to 0, a very small length. It is very, very small. And we are trying to find out for this dx unit, this very, very small length on the x-axis, that what is the probability of dx happening, this region happening, right? So if you do that, then it would be simply dx into breadth. Dx is the length, very small length, into breadth. We discussed in the last session that this breadth is going to be 1 upon b minus a. B and a are the two extreme value for the uniform continuous distribution, the left end and the right end. Okay. So dx into b minus a is actually your probability density function for a very, very small unit, a very, very small unit. And that is your true PDF. So this true PDF you can use anywhere because this is the PDF of a very, very small unit. You can also say this is the PDF of 1 unit of the uniform continuous distribution outcomes. So you can use it as a probability in any calculation. So the PI in the mean is actually what? Probability density function. If you remember, in the binomial distribution, we were saying PI is equal to PMF because that was discrete. But here I'll change the PI, the probability in the mean formula to PDF, and that is dx upon b minus a. This is the universal PDF formula for uniform continuous distribution. So I'll replace it. If I replace it, I'll use my finding one, that is PDF is equal to dx upon b minus a. Finding two, that in the continuous space, I'll use mean equal to integration instead of summation, integration of pi into xi. And what I have to do, I have to put pi is equal to dx upon b minus a, which I did, here, dx upon b minus a. But from where to where I will integrate? I'll integrate from a to b because that is my space. That is the different possible values of x. That is my space. So integrate from a to b. So dx upon b minus a integration should be done, but with the multiplication of xi. So it is xi dx upon b minus a. What is the integration of xi dx? If you don't know integration of xi dx, it doesn't matter. It doesn't matter. Just look into the integration of xi dx provided here. It is x square upon 2. Now, the problem with this is that because you have integrated from a to b, so your limits is a to b. So if you put it down the values of a and b into x square by 2, so it is b square minus a square by 2. So b square minus a square by 2, and definitely you were already dividing by 1 upon b minus a. If you expand b square minus a square, it will become b plus a, b minus a upon 2 b minus a, b minus a, b minus a get cancelled. At the end, you will get b plus a by 2. And that is the formula of mean that is given in your curriculum, b plus a by 2, where a and b are the extreme value in the uniform continuous distribution. The left hand and the right hand. Okay. Now the variance formula. Now the variance formula again apply the same logic. Variance is moment 2. If it is moment 2, do you remember the formula? It is summation of xi minus mu whole square upon n. However, this 1 by n has an assumption of equal probability. So the universal formula of variance is what? Summation of pi into x minus mu whole square. Okay. You have to replace this pi with what? Probability density function, which we discussed, dx upon b minus a. And you can solve it. But there is another formula of variance which we can use and which will help us to derive the variance, the final equation of variance very easily. However, you can also do dx upon b minus a into x minus mu whole square, integrate from a to b, you will still get the final result. But there is easier method to do that. The variance, another formula is what? Variance is equal to expected value of x square, not expected value of x, expected value of x square into expected value of x whole square. We already know that expected value of x for uniform continuous distribution is b plus a by 2. Why? Because expected value of x is equal to mean. So this is b plus a by 2. We just derived it. Okay, b plus a by 2. What is expected value of x square? Again, we have to find the expected value of x square by the formula of summation of xi square upon n, or summation of pi into xi square. Or if it is continuous distribution, I will use what? Integration pi into x square. Because the formula for mean is what? Summation of pi into xi. I'm saying give me the expected value of x square, not x. So pi x square. Now I will integrate it. If I integrate it, I have to replace this pi with what? Probability density function. We just proved that the probability density function is what? Dx upon b minus a, right? For a very small interval. So it becomes what? X squared dx b minus a. If you integrate it, it will become what? X cube upon b minus a. And definitely you will get 1 by 3 because that is the basic rule of integration. Now, if you use these limits of the integration, which is from a to b, it will become b cube minus a cube. And definitely you have 1 by 3 already there, which is not written here. So let me write it down. Okay. Now, if you cancel b minus a, then what you will left with? B square plus ab plus a square. So this expected value of x square is what? B square plus ab plus a square upon 3. What is b plus a whole square? Would be b square plus 2ab plus a square. And definitely 2 square would be what? 4. You have to subtract it. If you subtract it, you will find b square plus a square minus 2ab, which you can also write it as b minus a whole square, and the denominator LCM, you can see it as 12. And that is the formula for variance. See, I didn't want to like teach you that every step of finding out the mean or variance. But the intuition which is necessary now when you enter into continuous distribution is integration with the probability density function helps you to find out mean and variance. That is the core message of this session. So for continuous distribution, if anybody say how you find mean, how you find variance, how you find skewness and kurtosis, it is the integration with the help of the probability density function, whatever be the probability density function of normal distribution, chi-square F distribution, doesn't matter. The integration of probability density function with x minus mu whole square, with x minus mu whole cube, with x minus mu raised to the power 4 for moment 1, 2, 3, 4 will give you what? Mean, variance, skewness, and kurtosis final result. Okay. So with that, we'll end this session where we have introduced a very important concept that if you have to or if you want to derive mean and variance for any continuous distribution, not only uniform continuous distribution, you need PDF. That's it. Okay. Thank you. Have a nice day. We'll end the session here.